Next up, John Capp from General Motors. Tell us a little bit about what's going on there and some of the new technology as well.
Good afternoon. Thank you. I actually decided not to bring any slides with me, so we'll mix it up a little bit and see how it goes. Oh, yeah. Maybe I'll do that. Yeah. So, I wanted to talk about our perspectives on automated driving, active safety systems, autonomous vehicles, flying vehicles, all these things everybody's talking about. And actually already, two speakers ahead of me, Brian and Danny, and myself are going to say, this stuff's going to take a while. It's not going to happen overnight. And yet the media is just full of soaking up announcements that some people are making that, in 3 years and 2 years and things like that, that we're going to have autonomous cars for sale. So somebody's got to get the story straight. You guys are with the media. Ask questions. Let's talk about it. It's going to take a while. The 80 million lines of software code or whatever Danny showed, I mean, it's in the tens of millions that we have in all of our vehicles. Think about what it's going to take to get the reliability of that system to the point where I'm going to give a customer a brand new car that they just bought and said, go ahead, close your eyes, take a nap. You're good to go. It's going to work no matter what. This is the standard we got to get to. But it's not. I don't say that to be discouraging because we have so many great technologies that we're going to bring into the marketplace. So it's really exciting as we move towards automation. But this ultimate thing is a bit of a ways out. And my view is it's kind of a moot point because when it happens, because we have so much to do along the way and to enjoy. So a little bit of background. Myself, I am a long life General Motors engineer, mostly product engineering, although I'm currently work for our R&D organization. I'm responsible for planning all of our advanced technology work in the area of these automated type systems. But actually the majority of my career has been working on actual product. It kind of provides a good balance, a good mix. Safety systems, I've worked on airbags, I did body structures, CAE work on safety systems for many years, and I've been involved in these electronic safety systems for the last 8 years or so. And this is a lot more fun. We had been a part of an event called the DARPA Urban Challenge about 7 years ago. This was a competition that took place in Southern California on an abandoned Army base, and there were about 89 teams, universities, companies that got together and entered into this competition that we were going to drive without a driver even in the car on this simulated city course. It was about 60 miles long. And what that competition showed, I think, to a lot of people was that this idea of computers driving cars was really feasible. We actually happened to be part of a winning team with some partners of ours from Carnegie Mellon University and a supplier, Continental, that worked on that. But there were a lot of successful teams that did a lot of great work, and it was really a catalyst in this whole space. But it wasn't practical. That's already been mentioned today, too. The vehicle had about $200,000 worth of sensors on it, not quite the price points that we need to be at to keep our customers coming back. But it showed that it's feasible. We have since been working on really two work streams. One is how do we take that kind of technology and really work towards high levels of automation, high levels of active safety, but we're also working on a work stream of real stuff. We have to, I was telling people in a couple of talks like this in Detroit earlier in the year, where after I just came from the auto show in January, we need to fill the floor with new products every year, and those cars have to have new exciting technologies on them. So we can't afford to wait until, all of the automated technologies are perfected. But again, from an engineering standpoint, that's the fun of it. I don't want to wait to the last step. I want to be able to bring things into the marketplace when they're ready. And yet, despite all the new technologies that are showing up in new vehicles, the biggest crowds that I saw at the auto show this year was people standing around our new Corvette. So people still want to have their hands on the wheel. They still want to participate in driving, but they want these technologies. And so we're going to have to figure out, we already talked a little bit about the human factors, but we're going to figure out how to balance these, how to give consumers what they want, let them take advantage of the technologies, but the machine's going to have to communicate. We're going to have to sense what's going on, and when it's time to take over, we're going to need to tap the driver on the shoulder and say it's time to take over. Or if the driver wants to participate in driving, if they don't, we're going to have to figure out all of that in addition to all the the software and the robotics work. So these systems are going to have to grow up together, and that's another reason that it's going to take some time. So we've been deploying on real vehicles a number of technologies. We've talked a little bit today about lane departure warning, forward collision alert, adaptive cruise control, rear cross traffic, side blinds, and all these things have been showing up in the last few years. But yet, they're still not highly penetrated for the most part. People are still getting these in some of their new cars. They're optional systems. Some people have never experienced any of them. It'll take a while for people to get the experience. It'll take a while for the data to show up and see, are these systems providing the kind of benefit that we wanted them to and that we designed them to. But the other thing that's happening is that the ability to put these systems on more and more cars is increasing. We introduced just 2 years ago now a vision-based forward collision alert system that up to that point, up to just 2 years ago, the only way to do collision alert was using radar to sense the velocity of the relative to the vehicle in front of you. Using machine vision technology through some advanced work we did with a supplier partner of ours, we were able to do that feature now using vision. Well, that allows us to make a much more cost-effective system, and even on our Chevy Malibu, even down to our Chevy Sonic, you can buy a module today that retails for under $400, optional system that does lane departure warning and forward collision warning or forward collision alert with this vision system. So we can feed that into the market while we're also working on more advanced systems, which about 2 years ago, about a year and a half ago, we introduced on our line of Cadillacs a package we call the driver assist package. So this is now a high-end, state-of-the-art type system, highly integrated. It's got a central processing unit. It's got 3 radars in the front, 3 radars in the back, 6 total, 2 cameras, 8 or 10 ultrasonic sensors around the vehicle, depending on the model. And all these are collecting information, and we're fusing it to try to figure out what's happening around the vehicle. Now we can do more sophisticated features like crash imminent or crash mitigation, emergency automatic braking. There's lots of names for all these features. The adaptive cruise control that slows the vehicle down to a stop, keeps a safe pace to the vehicle in front of you after you just set the gap setting. So a system like that that has literally its own computer and it's talking to all these other systems. So to go forward from that, what's it going to take? Well, we're going to continue to work on advancements in better sensing, better processing. If we're going to collect more data from these sensors, we need better processing like we're talking about as to move fast. Reliable systems with millions and millions and millions of lines of code. We need to figure out ways to develop these systems in ways that are reliable. We need to develop them in a laboratory. We're not going to be able to have the opportunity to test out every conceivable encounter that a vehicle is going to come across in the real world. Today we drive our cars around over at our Milford Proving Ground in Michigan and over bumps and water things, and it used to be a time when you could test everything that a car would encounter in our laboratory in this plot of land in Milford, Michigan. But when you start talking about automated type systems, and it's impossible to simulate them all in a closed track. And so we're going to need to have very, very sophisticated development tools to be able to incorporate that into the software. So we've been working on a system that we think is a realistic step in the direction of automation. We've talked about it a little bit publicly over the last year or so, and it's called Super Cruise. And what Super Cruise does is take the adaptive cruise control system like we have available on our Cadillacs and some other models today, and also adds lane control or lane centering, lane following to it. And this is a system that's going to work on highways. It's going to allow people to take their hands off the wheel, their feet off the pedal, and enjoy a more relaxing, perhaps a more safe driving scenario on certain freeways and highways. And we think this is the type of technology that we can bring to the marketplace. This is what we're working on this decade. But this is a system that we're not promising is going to work in snow. It's not going to work in every single type of highway you drive on. It's not going to work in cities. So we're designing the system to work in conditions that we think the technology is capable of living up to the promise that we're going to make to the customer. And we think that a highway assistance system where the driver can take their hands off the wheel on freeways is an achievable system that we can deliver. But drivers are going to still have to pay attention even with a system like that. And so we're designing into the system a way to understand the attentiveness of the driver, and we'll be looking for cues and understanding what the driver's doing, and make sure that the driver doesn't get detached from the driving situation, because the technology that's going to be available just in the next few years isn't going to be able to react to any type of a situation that comes up. So we can't get too far astray. A lot of human factors work is going into that kind of a system, along with the driver assistance or the active safety features that we have today. We do a lot of studies with what we call naive participants, research studies, where we put people into cars that we've built up. We let people experience these types of features. We do that in a conjunction with some university partners we have that specialize in that kind of work. Expose people that aren't engineers to what these cars and these systems might be telling them, what they might do. And then we learn from that, because when we deploy these systems, we need to make sure that we're going to have desired consequences, not unintended consequences, as we referred to. We also want to make sure that these technologies, like the Super Cruise I'm talking about, gets off to a good start. Nobody wants to be deploying technologies that all of a sudden puts a black mark on a really exciting area of technology. And plus, vehicles are so important to people. They count on them for safety. It's not an area of technology that we experiment with lightly. So we think we've got a pretty robust roadmap for how to proceed step by step by step. It's going to take lots of years before vehicles can be fully entrusted to just do everything. But starting with a system like Super Cruise, highway assisted driving, in just a few years, we think we'll be able to take a big step, and then we'll start working on, we're already working on it in the laboratory and the research, but we'll be able to bring to the market, take that same level of capability and be able to help out in urban driving situations or more complex types of highways. Maybe let the driver enjoy the freedom of some of these technologies for a little bit longer period of time. And if you start adding up all these benefits, as the technology grows, the processing goes faster, we do better human factor studies, all of a sudden we're going to look back and we're going to say, golly gee, remember when we had to roll up our windows by hand? Or remember when you had to shift your own transmission? It's going to seem like that at some point in the future. But it may not be this step function. There's a lot of hype too that I encounter of, oh my God, the age of automated driving cars are coming, and we're going to have to redesign all the roads, and we're going to have to give people all new driver's licenses and training. And my message is kind of like, chill out a little bit. It's going to happen kind of gradually. And a lot of these other technologies that we've enjoyed, we didn't need to do anything special. My kids literally have no idea what this would mean to do in a car anymore, to make a window go up and down, but they'll be just fine. There's certain things that you don't have to know how to do. And part of designing cars the way customers want them and can adapt to them is making sure that we understand how they can use them. Nobody wants to develop a car and give it to a consumer when they say, how the heck do I operate this? So that's not a particular issue that I spend a lot of time worrying about. I think by the time any of these technologies are ready, it will include being very intuitive and easy for people to use, because that's what customers expect from us. So hopefully that gives you some perspective, and I assume in the panel discussion we'll have some fun talking about these things too. Thank you.
Thank you, John.